Ladies and gentlemen, I want to welcome you to our program this evening entitled States of Fear, Science or Politics. My name is David Thoreau, and I'm the president of the Independent Institute. We're delighted to have you join with us this evening, and we hope that you'll enjoy tonight's program. For those of you who are new to the Independent Institute, the Institute is a scholarly, non-political, non-partisan public policy research institute. The Institute sponsors in-depth studies by major scholars on important issues, not unlike tonight's. The results of this work is published as books and forms a basis for numerous conference and media projects. Almost 20 years ago, we founded the Independent Institute to pursue research into what was the actual nature and consequences of government policy, without regard to prevailing popular or political biases, trends, or phobias. We wanted instead to create an organization that would support scholars exploring important areas that might otherwise be ignored, including questions normally considered out of the box, irreverent, and certainly controversial, but which were crucial to our understanding of how to get to real answers to lasting solutions. As a result, the Institute was founded to cut through the intellectual poverty, noise, and spin of special interest-driven public policy in the US and around the world. In order to do so, we had to establish a new kind of research institute, one of a kind, frankly, in the public policy field, which is so dominated by highly partisan advocacy groups of every stripe. As a result, the Institute was started without the financial backing of any special interest, industry, labor, government, or otherwise. We had, in fact, no angels at all. But we had a deceptively simple ambition to pursue our work based solely on one and only one criterion. All of our studies had to be based on solid, peer-reviewed scholarship and science, period. In effect, we became the first garage think tank. And today we have over 140 research fellows at universities. So we invite you to get to know us better. We hope you'll enjoy getting beyond the stereotypes of left and right into the realm of innovative, bold ideas. We believe that such ideas are the key to a brighter future. Tonight's program, as you know, features Dr. Michael Crichton, the renowned best-selling author of such books as Jurassic Park, The Andromeda Strain, Prey, and his newest, State of Fear. Following Dr. Crichton's presentation, we will have a discussion with a distinguished panel of scientists. We're also pleased that our program tonight is co-sponsored by the World Affairs Council of Northern California and made possible by the kind and generous assistance of members of our host committee, and the names of those you can find on the program that each of you has received. I also want to especially thank Fred Hamden, John Campbell, Michelle Beardsley, and the entire staff of people at the Institute who have worked so hard in coordinating the many details that has made tonight possible. But most of all, I want to thank another person who really made tonight's program possible, and that's my son, Paul Thoreau. It was Paul who got me to read Michael Crichton in the first place. And he first alerted me to the fact that in Michael's book, State of Fear, Michael very kindly recommended one of our books called The Poverty of Reason by Oxford economist Wilfred Beckerman. It was this connection by Paul that directly led to our program this evening, and I'm deeply grateful, and I wanted to credit him for that. Incidentally, I want to invite each of you to pick up a copy, if you don't already have one, of the quarterly journal of the Institute, which is called The Independent Review. There are complimentary copies outside in the lobby. And in your program, you will also see information about our next event, which is on December 13th. We'll feature two scholars, one being Henry Miller, who's a senior fellow at the Hoover Institution at Stanford, and Bruce Ames, professor of biochemistry and molecular biology at the University of California. Tonight's program is of special significance to us at the Independent Institute because it deals directly with one of the most serious dilemmas I believe that we're facing today. Throughout the history of man, there have been theories and suppositions that people have had. In the program, we mentioned a couple of them, such as the geocentric or Ptolemaic theory of the universe, that once believed that the Earth was at the center of the universe, of the solar system. The eugenics movement, which was essentially supported by virtually every person of any standing in the US at one point. More recently, once our best medical minds thought peptic ulcers were a lifestyle disease, the result of too much stress, too much spicy food, and some combination thereof. And when Australian physician Barry Marshall suggested that perhaps ulcers might have a bacterial cause, his findings were utterly dismissed by colleagues as the most preposterous thing they'd ever heard, unquote. Sound familiar? Yet this year's Nobel Prize in Medicine to Dr. Marshall clearly illustrates that the history of science shows just because a scientific, quote-unquote, consensus on any subject does not mean that such consensus is correct or true. And errors in mainstream thinking often are discovered by investigators from outside orthodox circles. Before we begin, a couple of quick program matters. After the presentation, we will have questions from the audience. In your programs, you'll find a card, and you're welcome to write your question on that. Please simply jot it down, and there'll be ushers circulating in the aisles to pick them up. After the question period, we will adjourn. And Dr. Crichton has kindly offered to autograph copies of his book, State of Fear, which will be done in the outer lobby. Michael Crichton himself is widely regarded as the father of the techno-thriller. He's the author of 21 books, some of which I just mentioned. His books have sold more than 150 million copies, translated into 36 languages, with 12 made into films. He's the recipient of an Emmy, a Peabody, Writers Guild of America Award for the TV series ER. Dr. Crichton is a graduate of Harvard Medical School and has been a visiting lecturer in anthropology at Cambridge University, Henry Russell Shaw Traveling Fellow, postdoctoral fellow at the Salk Institute for Biological Sciences, and visiting writer at MIT. Michael has challenged and thrilled people worldwide with his insights and creativity, and his devotion to truth-seeking regarding scientific matters is our topic this evening. Hence, it gives me great pleasure to introduce Michael Crichton.
Thank you, David. That was very nice. I was quite impressed with myself. I'm going to try and sit tonight, if that's okay. Most people think I'm too tall already. I'm going to challenge you tonight to revise your thinking and to reconsider some fundamental assumptions. Assumptions that are so deeply embedded in our consciousness that we don't even realize that they're there. This is a map by the artist Tom Friedman. You know, I have to tell you that my favorite example of making the wrong assumption is a story about a man who goes on vacation and leaves his cat with his best friend. And he's on vacation, and the friend calls him up and says, "Listen, I've got some bad news. The cat got up on the roof and we can't get it down. We called the fire department. They came. The cat jumped to a tree. They went up the tree, but anyway, the cat fell. And the cat's dead." The guy said, "Oh my God!" He said, "How can you tell me in this way?" And he said, "Well, how should I have told you?" And he said, "Well, you have to prepare me." He said, "The first day you should have called and said, 'Listen, the cat's on the roof and we can't get her down.' Then the second day you call and you say, 'The fire department's here and the cat's jumped to the tree.' And the third day you call me and you say, 'The cat died.' And by then I'm prepared." The guy says, "Oh, that's the way you want it?" He said, "Yes." Continues his vacation, gets a call a week later, and his friend says, "Listen, Your mother's on the roof and we can't get her down. So this is a map, and the assumptions that I'm going to talk to you about today are not getting your mother down, but another kind of a map that tells us how the world works. And particularly, I would like to try and direct our attention to the notion that most people make the assumption of linearity in a world that is largely nonlinear. I hope that at the end of this talk, the meaning of that statement will be clear, but we won't be getting there in a linear fashion. Some of you know that I've written a book that many people find controversial called State of Fear. And I want to tell you how I came to write it. Because up until about 5 years ago, I had very conventional ideas about the environment and the environmental movement. This book really began, is that mine? Cool, thank you. This book really began in 1998 when I had decided to write a novel about a global disaster. That was one of the first books I'd written, and I thought, well, I'm old now, I'll write another one. And in the course of my preparation for this book, I rather casually reviewed what had happened at Chernobyl, because I regarded Chernobyl as the largest man-made disaster that I knew about. What I discovered stunned me. Chernobyl was a tragic event, but nothing remotely close to the global catastrophe that I was imagining. About 50 people had died in Chernobyl, roughly the number of Americans that die every day in traffic accidents. I don't mean to be gruesome, but it was a setback for me. You can't write a novel about a global disaster in which only 50 people die. I was undaunted. I began to research other kinds of disasters that might fulfill my novelistic requirements. And that's when I began to realize how big our planet really is and how resilient its systems ordinarily seem to be. Even though I wanted to create a fictional catastrophe of global proportions, I found it hard to come up with a credible example. I couldn't actually come up with anything that I would believe. So in the end, I set the book aside and wrote something else. But the shock that I had experienced reverberated in me for a while, because what I'd been led to believe about Chernobyl was not merely wrong, it was astonishingly wrong. Let's review that for a minute. These are the low estimates of immediate Chernobyl deaths as a consequence of the actual incident. And you see here the UPI in 1986, at the time of the disaster, predicted that there would be 2,000 immediate deaths. The New York Post thought there would be 16,000. The Canadian Broadcasting Company in '91 thought there would be that many. And you see the BBC and the New York Times in 2002 predicting at the low end 15,000 deaths. Their estimates were 15,000 to 30,000 deaths. Now, there was a UN commission in 2000 that suggested that the catastrophe was nowhere near that proportion. And as you can see, the next UN commission in 2005 doesn't really show up on the graph because the total numbers are 56. Now, to report that 15 to 30,000 people are dead when the actual number is 56 represents a very large error. To get some idea of just how big, let's imagine that we lined all the victims up in a row. If 56 people are each represented by 1 foot of space, then that's probably the distance from me to about this second table here, something like that. 15,000 people is 3 miles away. It seems difficult to make a mistake of that scale. But of course, you're probably thinking, we're talking about radiation, what about long-term consequences? Unfortunately for the media, their reports are even less accurate here. Here you see CNN in 1996 was predicting future Chernobyl-related illnesses and death in a large swath that would go from Sweden to the Baltic, to the Black Sea, estimating 3.5 million. The BBC, much more conservatively, estimated 50,000. Agence Presse thought 500,000. The Ukrainian Victims Group in 2002 estimated 150,000. The UN Commission in 2005 decided that there would be about 4,000. That's the number of Americans who die of adverse drug reactions in this country every 6 weeks. Again, a huge error. But most troubling of all, according to the UN report, was that the largest public health problem created by the accident was the damaging psychological impact due to a lack of accurate information.
Wow.
This was manifesting, as they said, as negative self-assessments of health, belief in a shortened life expectancy, lack of initiative, and dependency on assistance from the state. In other words, the greatest damage to the people of Chernobyl was caused by bad information. These people weren't blighted by radiation so much as by terrifying but false information. We ought to ponder for a minute exactly what that implies. We demand strict controls on radiation because it's such a health hazard. But clearly, Chernobyl suggests that false information can be a health hazard as damaging as radiation. I'm not saying that radiation is not a threat. I'm also not saying that Chernobyl is not a genuinely serious event. But thousands of Ukrainians who didn't die were made invalids out of fear. They were told to be afraid. They were told they were going to die when they weren't. They were told their children would be deformed when they weren't. They were told they couldn't have children when they could. They were authoritatively promised a future of cancer, deformities, pain, and decay. It's no wonder they responded as they did. In fact, we really need to recognize that this kind of human response is very well documented. Authoritatively telling people they are going to die can in itself be fatal. You may know that there's an Australian Aborigine, that the Aborigines fear something called pointing the bone. A shaman shakes a bone at a person, sings a song, and soon after the person dies. This is a specific example of a phenomenon generally referred to as hex death. A person is cursed by an authority figure and subsequently dies. According to medical studies, the person generally dies of dehydration, implying that they just give up. But the progression is very erratic, and shock symptoms may play a part, suggesting adrenal effects of fright and hopelessness. Yet this deadly curse is nothing but information, and it can be undone with information. A friend of mine was an intern at Bellevue Hospital in New York when a 28-year-old man from Aruba came in saying he was going to die because he'd been cursed. He was admitted for psychiatric evaluation and found to be normal, but his health steadily declined while he was in the hospital. My friend was able to rehydrate him, balance his electrolytes, and give him nutrients, but nevertheless the man worsened. He insisted that he was cursed and that nothing could be done to prevent his death. My friend realized that this patient would, in fact, soon die. The situation was desperate. Finally, he told the patient that he, the doctor, was going to invoke his own powerful medicine to undo the curse, and his medicine was more powerful than any other. He then got together with the house staff, bought some headdresses and rattles, and danced around the patient in the middle of the night, chanting what they hoped would be effective-sounding phrases. I think several of them were trying to remember their bar mitzvah. The patient showed no reaction, but the next day he began to improve. He went home a few days later, and I would say that my friend literally saved his life. This suggests that Ukrainian invalids are not unique in their response, but that the large numbers of what we might call information casualties represent a particularly egregious example of what can happen from false fears. Well, once I looked at Chernobyl, I began to remember some other fears in my life that had also never come true. The population bomb, for one. Paul Ehrlich predicted mass starvation in the 1960s. 60 million Americans starving to death. That didn't happen. Other scientists warned of mass species extinctions by the year 2000. Ehrlich himself predicted that half of all species would become extinct by 2000. That didn't happen. The Club of Rome told us we would run out of raw materials ranging from oil to copper by the 1990s. That didn't happen either. It's no surprise that predictions frequently don't come true, but such big ones, and so many, All my life, I worried about the decay of the environment, the tragic loss of species, the collapse of ecosystems. I worried a lot. Poisoned by pesticides, alar in apples, falling sperm counts from endocrine disruptors, cancer from power lines, cancer from saccharin, cancer from cell phones, cancer from computer screens, cancer from food coloring, hairspray, electric razors, electric blankets, coffee, chlorinated water. It never seemed to end. Only once, when on the same day I read that beer was a preservative of heart muscle and also a carcinogen, did I begin to realize the bind that I was in. But Chernobyl started me on a new path. When I began to research these old fears to find out what had been said in the past, I discovered several important things. The first is that there's nothing more sobering than a 30-year-old newspaper. You can't figure out what the headlines mean. You don't know who the people are. Theodore Green, John Sparkman, George Reedy, Jack Watson, who are they? You thumb through page after page of vanished concerns, issues that apparently were important at the time and now don't matter at all. It's amazing how many pressing concerns are literally of the moment. They won't matter in 6 months, and certainly not in 6 years. And if they won't matter then, are they really worth our attention now? But as David Brinkley once said, the one function TV news performs very well is that when there is no news, we give it to you with the same emphasis as if there were. We miss him. I think we... The second thing I discovered was that attempts to provoke fear tended to employ a certain kind of stereotypic and very intense language. For example, here's a quote on climate. We simply cannot afford to gamble by ignoring it. We cannot risk inaction. Those scientists who say we are merely entering a period of climate instability are acting irresponsibly. The indications are that our climate can soon change for the worse are too strong to be reasonably ignored. Familiar language, isn't it? But this is not actually about global warming. It's about global cooling. Fear of a new ice age. Is anybody here worried about an ice age? Is anybody upset that we didn't act now, back then, to stockpile food and all the other things we were warned that we had to do? Here's a quote from a famous computer study in the 1970s that predicted a dire future for mankind unless we act now. And just notice the language here. We're unanimously convinced that rapid, radical redressment of the present unbalanced and dangerously deteriorating world situation is the primary task facing mankind. Concerted international measures and joint long-term planning will be necessary on a scale and scope without precedent. This supreme effort is founded on a basic change of values and goals at individual, national, and world levels. Very heavy stuff. Here's Paul Ehrlich talking about what he thinks we're going to have to do. He's talking about population. As you know, he favored voluntary controls, but if voluntary controls didn't work, he favored coercive controls. He said the operation will demand many apparently brutal and heartless decisions. The pain may be intense, but the disease is so far advanced that only with radical surgery does the patient have a chance of survival. Here's the UN. This is about Y2K. History offers no example of a parallel threat on a global, national, or local scale. To wait and see invites disaster. A worldwide strategic mobilization similar to the effort required by World War II must be developed in the weeks ahead. Now, nearly everybody's forgotten about Y2K, so let me remind you of what was predicted 6 years ago. Here's one author who said he was assuming at least a 12-month disruption of basic goods and services, including no electrical power, no clean water, no telecommunications, shortages of food, gas, clothing, and retail goods, bank failures, inaccessibility of funds, stock market crash, dramatic drop in real estate prices, we're still waiting for that, economic depression, unemployment, civil unrest, including protests, riots, and general lawlessness. This is actually one of the milder predictions. Here's another prediction that simply pointed to a meltdown of civilization as we know it. Can't get any stronger than that. But what actually happened? Essentially nothing. And the UN was pleased. During the first months of the new century, only minor problems were reported. The governments can congratulate themselves for passing the Y2K challenge.
Yeah.
Now, there's only one problem. The governments didn't really have anything to do with it. And you may think, well, wait a minute, Y2K was a real problem, and the concerns, even if they were exaggerated, nevertheless mobilized people and led them to success. This is a common but entirely erroneous view. The government, it's easily demonstrated here. The United States government on Y2K spent $6 billion. Citibank alone spent nearly $1 billion. And total US expenditures were in the region of $100 billion, which means the government spent 6% of the total. Globally, as you can see, there were $200 billion in expenditures. So you see something like this. And so here's the United States government, and we are asked to imagine that it is responsible for saving us from this crisis. Would Citibank have spent the money to fix its Y2K problem without government urging? Of course, because not to do so would have put them out of business, and the same with other banks and businesses around the world, yet government takes credit. To encourage what is happening anyway is a common strategy in many areas of advocacy. For example, it now seems clear that despite the warnings of Paul Ehrlich and others, we are not going to have a population explosion of 14 billion people and accompanying mass starvation. How did we avoid this explosion? Because, the head of Planned Parenthood once explained to me, everybody in the world listened to Ehrlich and got busy stopping population growth. Yeah, right. I could see in my mind Yemeni tribesmen, finding a copy of the book. But the more significant point is I was really astonished that she was so ill-informed about her subject area, because Ehrlich may be a celebrity in the West, but his advocacy had little to do with solving the problem of population, because that problem was already being solved by itself at the time he wrote the book. Here's a graph from the World Bank. It's not very easy to understand, but it's the World Bank. And if we look here at where Ehrlich's book appeared, you see that it's hard for me to follow it. Anyway, the birth rate in developed countries was falling for about 100 years at that point, and in the developing nations, it had been falling for close to a decade. Ehrlich was thus urging people to do what they had already been doing for some time, and it's not clear to me whether he knew that or not, but certainly when he said, "The battle to feed all humanity is over. At this late date, nothing can prevent a substantial increase in the world death rate," that he's simply wrong. You can see the death rate here for the developed countries and the death rate here for the developing countries, and as you see, it never went up. Ehrlich's message, crying out in desperation to urge what's already happening, is not unique. We have a contemporary example of the call by politicians and activists to end our dependence on fossil fuels and move to a carbon-neutral lifestyle. Their call to action is, however, a little bit late. According to Jesse Ausubel, the Rockefeller Institute, the industrialized nations have been decarbonizing their energy sources for 150 years, meaning that we are moving away from carbon toward hydrogen. In other words, the ratio of carbon to hydrogen decreases as you go from wood and hay, which is 1:1, to coal, to oil, and finally to natural gas, where it's 1:4. Here's an illustration from one of Ausubel's articles. The blue atoms are hydrogen, and the dirty brown ones are carbon. And you can see, as we go from coal to oil to gas, natural gas, if there's still any for sale, we are increasing the proportion of hydrogen to carbon. Ausubel expects this trend will continue through this century as we move toward what he imagines as a pure hydrogen energy system without the assistance of lawyers and activists. Obviously, if a trend has been continuously operating since the days of Lincoln and Queen Victoria, it probably does not need the assistance of organizations like the Sierra Club and the NRDC, which are showing up about 100 years too late. Ausubel's ideas are controversial to some, but not to sites like Sustainability Now. And this is again showing you the ratio of hydrogen and pure clean blue to carbon and other various sources. All right. So in summary, when I went back to look at old fears, the first thing I found was that newspapers were largely empty. The second thing I found was that the language was uniformly and excessively frightening. And the third thing I found was that a lot of advocacy was encouraging what was happening anyway. But I learned some other things too. One interesting feature is the tendency toward reversals. A benefit becomes a hazard and then becomes a benefit again. Butter is good, then it's bad, then it's good. Saccharin is good, then it's bad, then it's good again. But this is also true for some much larger scares like cancer and power lines, which hit the media in 1989. Before 1989, there were books like this, which saw magnetic fields as necessary for life. Then in 1989, Paul Broder's articles in the New Yorker magazine, a source of erroneous scientific information for many decades, and his strong position brought people that agreed with him. Here's a consumer's guide to the issues of electromagnetic fields and how to protect ourselves. But then a funny thing happened. After about a decade, magnetic fields were rehabilitated. And you can chart that progression here. This is 1997, 1998, 2000, 2001. Now it's getting sexy. And finally, it's kind of new agey. Now, the end stage of this process is something like this. Here is an ad that says that tells you that you need to get this magnetism that exists in the Earth, but since nature is drastically depleted, this environmental supplement is incredibly important. And they will sell you magnets to increase your supply of it. Now we see we've completed the circle from fear to selling point, from magnetic fields that are too powerful for health to fields that are too weak for health. Of course, rather than buying these magnets, you could just stand alongside a power line. Or sit with your back to a TV set. Snuggle up to a kitchen appliance. There's lots of ways to increase your exposure to healthful magnetic fields. I'm reviewing these past fears not to make fun of them, but because I think this back and forth quality, that's the fears that suddenly rise and subside, is symptomatic of a deeper problem with modern environmental thinking, a problem that we have to fix. But meanwhile, the fears do continue to rise and fall. Let's look at some graphs of past fears. To get a rough idea of the visibility of fears, I did a word search on Nexus for two newspapers, the Washington Post and the New York Times. These provide very rough measures, but they'll show you a trend. Here's the graph for power lines and cancer. As you can see, not much interest, a peak following Broder's book, a decline here, which I think is people sensibly saying, wait a minute, and then the thing has its own momentum and slowly declines as the whole thesis unravels. Cost of this thing is about $25 billion, start to finish. A similar sort of pattern we have for the population explosion. This may be a little hard to see, but we can run a 5-year average of, this is articles that appeared in the New York Times, and you can see finally we are in serious decline. If this were a stock, sell it. And finally, here is a much sharper peak for Y2K. As you see, a sudden spike, 2 articles a day in the Washington Post in 1999, and then it collapsed to almost nothing. This later drift upward appears to have 2 causes. First, there's a band called Y2K, and second, there's a steady trickle of self-congratulatory articles in which people say it's wonderful that we stopped the dreaded crisis in time. But I only want to emphasize the pattern, new fears rising and falling to be replaced by others that rise and fall. As Mark Twain said, I've seen a heap of trouble in my life, and most of it never came to pass. But I've suggested that this pattern is in itself indicative of a problem in how we approach the environment. And I'd like to talk about that now. Environmental disputes frequently revolve around conflicts of land use triggered by fears. The spotted owl is endangered, and that means logging in the Northwest must stop. People are put out of work, communities suffer. It may be in 10 or 30 years that we discover that logging was not a danger to the spotted owl, or it may be that we discover it was. But my point is that the drama surrounding these disputes, angry marches, press coverage, tree hugging, bulldozers, serves to obscure the deeper problem. The deeper problem is we don't know how to manage the environment even when there's no conflict at all. There's a good example of why. Let's take a case history of our management of the environment, Yellowstone National Park. This is the welcome sign. Long recognized as a scene of great natural beauty, in 1872, Ulysses Grant set aside Yellowstone as the first formal nature preserve in the world. More than 2 million acres, larger than Delaware and Rhode Island combined. John Muir was very pleased when he visited in 1885, noting that under the care of the Department of the Interior, Yellowstone was protected from, quote, the blind, ruthless destruction that is going on in adjoining regions. Theodore Roosevelt was also pleased in 1903, when as president he went to Yellowstone for a dedication ceremony. Here he is. This was his 3rd visit. Roosevelt saw 1,000 antelope, plentiful cougar, mountain sheep, deer, coyote, and many thousands of elk. He wrote, at that time, our people should see to it that this rich heritage is preserved for their children and their children's children forever, with its majestic beauty all unmarred. But in fact, Yellowstone was not preserved. On the contrary, it was altered beyond repair in a matter of years. By 1934, the Park Service acknowledged that white-tailed deer, cougar, lynx, wolf, and possibly wolverine and fisher are gone from the Yellowstone. What they didn't say was that the Park Service was solely responsible for the disappearances. Park rangers had been shooting the animals for decades, even though that was illegal since the Lacey Act of 1894. But they thought they knew best. They thought their environmental concerns trumped any mere law. What actually happened at Yellowstone is a cascade of ego and error. But to understand it, we have to go back to the 1890s. Back then, it was believed that elk were becoming extinct, so these animals were fed and encouraged. Over the next few years, the number of elk in the park exploded. Here you see them feeding them, hand to hand. Roosevelt had seen a few thousand animals on his visit, and he'd noticed that the elk were more numerous than in his previous visit. 9 years later, in 1912, there were 30,000 elk in Yellowstone. By 1914, there were 35,000. But things were going very well. Rainbow trout had also been introduced, and although they crowded out the native cutthroats, nobody really worried. Fishing was great. Bears were increasing in numbers, and moose and bison as well. By 1915, Roosevelt realized the elk had become a problem, and he urged scientific management, which meant culling. His advice was ignored. Instead, the Park Service did everything they could to increase the number of elk. The results were predictable. Antelope and deer began to decline. Overgrazing changed the flora. Aspen and willows were being eaten at a furious rate and did not regenerate. Large animals and small began to disappear from the park. In an effort to stem the loss, the park rangers began to kill predators, which they did without public knowledge. Here's a ranger in 1927 with wolf cubs, a very cute picture. This is a result of the policy of going into wolf dens and killing all the animals and wiping out the entire den. Shooting cougar. They eliminated the wolf and the cougar, and they were well on their way to getting rid of the coyote. Then a national scandal broke out. New studies showed that it wasn't predators that were killing the other animals, it was overgrazing from too many elk. The management policy of killing predators therefore had only made things worse. Actually, the elk had so decimated the aspen that now, formerly they were plentiful, now they're quite rare. Here you see them protected in a little stand. Without the aspen, the beaver, which used these trees to make dams, began to disappear from the park. Beaver were essential to the water management of Yellowstone, and without dams, the meadows dried hard in summer, and still more animals vanished. The situation worsened further. It became increasingly inconvenient that all the predators had been killed off by 1930. So in the 1960s, there was a sigh of relief when new sightings by rangers suggested that wolves were returning. Of course, there were rumors all during that time, persistent rumors that the rangers were trucking them in. But in any case, the wolves vanished soon afterward. They needed to eat beaver and other small rodents, and the beaver had gone. Pretty soon, the Park Service initiated a PR campaign to prove that excessive elk were not responsible for the problems in the park, even though they were. The campaign went on for about a decade, during which time the bighorn sheep virtually disappeared. Now we're in the 1970s, and bears were recognized as a growing problem. They used to be considered fun-loving creatures, and their close association with human beings was encouraged in the park. Here's people coming to watch bear feedings as a show at a certain hour of the day. And here's one of my favorites, setting the table for bears at Lake Camp in Yellowstone Park. You see they're very well behaved. But that didn't actually continue. And now it seemed that there were, good behavior, there were more bears, and certainly there were many more lawyers, and thus a much increased threat of litigation. So the rangers moved the grizzlies out. The grizzlies promptly became endangered. Their formerly growing numbers shrank. The Park Service refused to let scientists study them, but once they were declared endangered, the scientists could go back in again. And by now, we're about ready to reap the rewards of our 40-year policy of fire suppression, Smokey the Bear, and all of that. The Indians used to burn forest regularly, and lightning causes natural fires every year. But when these are suppressed, branches fall from the trees to the ground and accumulate over the years to make a dense ground cover such that when there is a fire, it is a very low, very hot fire that sterilizes the soil. In 1988, Yellowstone burned. In all, 1.2 million acres were scorched, and 800,000 acres, 1/3 of the park, burned. Then, having killed the wolves, having tried to sneak them back in, they officially brought the wolves back. And now the local ranchers screamed. But newer reports suggest that the wolves seem to be eating enough of the elk that slowly the ecology of the park is being restored. Or so it is claimed. It's been claimed before. And on and on. As the story unfolds, it becomes increasingly impossible to overlook the cold truth that when it comes to managing 2.2 million acres of wilderness, nobody since the Indians has the faintest idea how to do it. And nobody asked the Indians because the Indians managed the land very aggressively, very intrusively. The Indians started fires regularly. They burned trees and grasses. They hunted the large animals, elk and moose, to the edge of extinction. White men refused to do that and made things worse. To solve that embarrassment, everybody pretended that the Indians had never altered the landscape. These pioneer ecologists, as Stuart Udall once called them, did not manipulate the land. But now, in recent years, the wisdom of Indian land management policies is increasingly difficult to cover up. All right, if we're going to do better in this new century, what must we do differently? What is the story of Yellowstone really telling us? I would argue that in a phrase, we must embrace complexity theory. We must understand complex systems. We live in a world of complex systems. The environment is a complex system. The government is a complex system. Financial markets are complex systems. The human mind is a complex system. Most minds, anyway. By a complex system, I mean one in which the elements of the system interact among themselves such that any modification we make to the system will produce results that we can't predict in advance. In addition, a complex system is sensitive to initial conditions. You can get one result from it on one day, but the identical interaction the next day will yield a different result. We cannot know with certainty how the system will respond. Third, when we do something to a complex system, we may get downstream consequences that emerge weeks or even years later. We have to be watchful for delayed and untoward consequences. The science that underlies our understanding of complex systems is now 30 years old. A third of a century is plenty of time for this knowledge to filter down to everyday consciousness, but except for slogans like the butterfly flapping its wings and causing a hurricane halfway around the world, not much has really penetrated general human thinking. On the other hand, complexity theory has raced through the financial world. It has been briskly incorporated into medicine. But organizations that care for the environment don't seem to notice that their ministrations are often deleterious in many cases. Lawmakers don't seem to notice when their laws have unexpected consequences. Or maybe they notice, but they don't want to notice. Governments and governors and mayors and managers may manage their complex systems well or badly. But if they manage well, it is usually because they have an instinctive understanding of how to deal with complex systems. Other managers fail. Why? Our human predisposition is to treat all systems as linear when they're not. A linear system is a rocket flying to Mars, or a cannonball fired from a cannon. Its behavior is quite easily described mathematically. A complex system is water flowing over rocks, or air flowing over a bird's wing. The mathematics are complicated, and in fact, no understanding of these systems was possible until the widespread availability of computers. One complex system that most people have dealt with is a child. If so, you've probably experienced that when you give the child an instruction, you can't be certain what the response will be, especially if the child is a teenager. And similarly, you can't be sure that an identical interaction on another day won't have a spectacularly different outcome. So if you have a teenager or if you invest in the stock market, you know that a complex system cannot be controlled, it can only be managed. Because its behavior cannot be predicted, it can only be observed and responded to. An important feature of complex systems is that we don't know how they work. We don't understand them, we just interact with them. Whenever we think we understand them, we learn we don't. What then happened in Yellowstone? I would argue people thought they understood the system, and they were wrong. Let's look back. Here's the 1970s, the Club of Rome, yellowing with age. And they had a chart back then to explain what regulates fertility. It's surprisingly simple. The problem is that some years later, most professional demographers no longer believe that they can predict precisely the future growth rate, size, composition, and spatial distribution of populations. This graph at the top is silly. And there are many others. Here's one of my favorites. This gets population, and industrial capital, all on one single page. It's really fantastic. Okay. Highly simplified thinking, and it goes on to this day. Here is a modern chart from a sustainability website. It shows the relationships of pretty much everything: lithosphere, biosphere, market, community, customers. Okay, who makes a chart like this? I'm asking a serious question. Who thinks the world operates in this way? Because look, it does not explain the world. One side is not an explanation of the other side. In fact, the chart showing everything is absurdly simple. Here, for example, is a more complex diagram. It represents the nerves of the stomach of the lobster. And look, this kind of simplification doesn't even explain man-made complex system. Here's a financial market, and we all know that if you were to make one single change, say increase the price of crude oil or charge a White House aide with a felony, you could not be sure how the financial system would react. Nobody knows in advance. People make their businesses out of trying to figure it out, but nobody knows except for inside traders. And that's the same for financial systems all around the world. Here's an article from the New York Times which suggests that we can't even know the simplest things about our financial status. Is the nation's productivity going up or down? Nobody knows. If you can't even understand the basic aspects of man-made systems, what makes anybody think that we can understand natural environments that are thousands of times more complicated? This is a storm hundreds of miles across. And we have, on the nightly news, people who will tell us what causes them, how they operate, and it's really simple answers. It's an extraordinary thing that this amazing thing, which actually we haven't really been able to see in this way until we had satellites, is translated into such simple forms of thought. It's nonsense to think that you can know its behavior and its causes. Similarly, at the microscopic level, here's hemoglobin, a single molecule that we've studied for decades and are only beginning to really understand. As you see, hemoglobin is far more complicated than the original drawing that I showed you, which is a drawing of everything. A single molecule in a single cell is more complicated than that drawing of the entire world. The heart that pumps these red cells is driven by an electrical stimulus that spreads across the heart muscle in a very complex way, a way that is now understood with the help of complexity theory. This is a conventional image, and here is a video image of conduction from Duke University 5 years ago, showing this in terms of how the conduction impulse spreads. And when you see images like this, you realize we're very far from the notion that how you proceed is just shoot a few wolves or shoot all the wolves. The natural world is vastly more difficult. But this kind of understanding of natural processes, the kind of understanding that you get from complex systems, is precisely what has been missing from environmental thought. 30 years later, I argue it's time to catch up. Stop worrying about decarbonization, which is taking care of itself, and start worrying about Yellowstone, which isn't. It's mesmerizing, isn't it? Okay, so what happened at Yellowstone? I would say somebody really believed that the world operated like this, and they acted on that belief. Kill the wolves, save the elk. Move the grizzlies, avoid the lawyers, and on and on. It's this kind of thinking that has to go, but we haven't learned that lesson. Here is a more recent story which suggests that we're going to kill barred owls in order to save spotted owls. Here on Santa Cruz Island, we're going to kill the wild pigs, but actually it's a little more complicated because there's eagles on the island. First we have to kill all the eagles, then we have to kill the wild pigs in order to save the foxes. Here's the notion that bringing the wolves back has actually reshaped Yellowstone and made everything wonderful again. My argument is we can only have these simple ideas if we don't really understand what a complex system is. We're like the blonde who returned the scarf because it was too tight. I'm sorry, I have a daughter who's blonde and I have a wife who's blonde. I have to tell you the story about the lawyer who got on the airplane and found himself, to his delight, seated next to an incredibly beautiful blonde who was turning away to go to sleep, and he didn't want her to do that, so he said, let's play a game. I'll ask you a question, and if you can answer it, I'll pay you $5, and if you can't, you pay me $5. And then you ask me a question, and the same. She said, no, and turned away to go to sleep. He said, okay, wait. I'll ask you a question, and if you can't answer it, you pay me $5, and you ask me a question, and if I can't answer it, I'll pay you $500. She sat up very alert. So he said, I'll go first. And his first question was, what is the capital of Alabama? Blonde reached in her purse, gave him $5. He said, okay, it's your turn. She said, what goes up the hill on 3 legs and down the hill on 4? He said, he got out his laptop, he Googled it, he did everything that he could. And he finally had to realize that he couldn't answer it. He gave her $500. She put it in her pocket. He said, what's the answer? She gave him $5. Fortunately, we can learn to manage complex systems. There are people who have studied how to do it and know how to do it. But it does take humility. And with that, something very important, the ability to admit that we're wrong and to change course. If you manage a complex system, you will frequently, if not always, be wrong. You have to backtrack. You have to acknowledge error. You've probably learned that with your children, or if you don't have children, with your bosses. And one other thing, we have to not be afraid. Fear may produce a television audience, it may generate cash for an advocacy group, but fear paralyzes us, it freezes us. And we really need to put that behind us as we move into a new era of managing complexity. Because, look, here's the Independent, the future of the earth. Is this the end of the world? Earthquakes, hurricanes, floods. What is happening to our planet? Is this the end of the world? No. We live on an active planet. Earthquakes are continuous, 1.5 million a year, or 3 every minute. A Richter 5 every 6 hours. A major quake every 3 weeks. This is all the earthquakes in California in the last week. There's a quake the size of Pakistan every 8 months. This is Kobe in Japan. Despite building codes, the buildings just topple. Very good building codes. At any moment on our planet, there are 11 lightning strikes every second. There are 1,500 electrical storms on the planet at any moment. A tornado touches down every 6 hours. A tidal wave crosses the Pacific every 3 months. There are 90 hurricanes a year, 1 every 4 days. It's constant. Is this the end of the world? No, this is the world. And I think it's time we knew it. Thank you very much.
Thank you very much, Michael. Before we turn directly to our panel of scientists, I'm pleased to introduce a member of our host committee, if he'd come up, please. Dr. Bruce Ames is professor of biochemistry and molecular biology at the University of California, Berkeley. Professor Ames has received the National Medal of Science from the National Science Foundation, the Tyler Prize, which is the highest award for environmental achievement, the Golden Medal Award of the American Institute of Chemists, and the Japan Prize, among others. He has served on the National Cancer Institute Board of Directors, and he is a member of the National Academy of Sciences and the Royal Swedish Academy of Sciences. And Bruce very kindly has offered to make a few brief comments.
So I was asked to say a few things about my interaction with the environmental movement, which hasn't been completely happy, but I'll talk about it anyway. So my passion is preventing disease, and for many years I was interested in preventing cancer. And if you ask all the world's leading epidemiologists who've studied the subject, they come up with about the same list. Smoking is about a third of cancer. Bad diets are another third of cancer. Chronic infections, mostly in poor countries, hepatitis and schistosomiasis, all sorts of things like that. Helicobacter in your stomach, as we heard about 20%. Hormones cause a lot of cell division, all of that, and responsible for breast cancer, endometrial cancer. Occupation, a few percent. And pollution, the numbers vary, it's all a guess, but it isn't much. And this less than one is my own estimate, mostly heavy air pollution. But this is where spending all the money by orders of magnitude. So something's wrong if we're putting our money on minor hypothetical risks and the major risks are not attended to. Next slide. So, well, we heard about the big cancer epidemic, but there isn't any cancer epidemic other than due to smoking. If you look at cancer attributed to smoking, it's going up, but if you look at cancer not attributed to smoking, it's been going down. In fact, it's been going down for a long time. So, there isn't a cancer epidemic other than that due to smoking. There's 30-year delay after people smoke. Next. So, and every week there's a scare story in the newspaper. It says, well, this new study says yes, but over 120 previous studies say no. Did you hear that, folks? The answer is yes. And I think the reason is that it sells newspapers. And so people are interested in poisoned apples. They're not interested in non-poisoned apples. So, next slide. So what about carcinogens? And so towards the end of the 1800s, when the chemical industry was going, we learned that some workers who were waiting around in beta-naphthalamine and putting their hands in it and breathing it in got bladder cancer. In fact, a high percent of all the workers doing that got bladder cancer. So people realized chemicals can cause cancer. And so then we didn't want our workers to be guinea pigs, so we started testing these chemicals in rats. And we made a number of assumptions. One, well, since workers got cancer from these synthetic chemicals, it's synthetic chemicals causing all the cancer. And two, we'll test it on rats and mice, which are relatively cheap, and we'll feed them the maximum tolerated dose every day of their lifetime and see if they get cancer. And the reason for that is it's expensive, and the statistics in small numbers of animals, a third of the animals get cancer anyway, just from living. And then we said, well, we can go from this huge dose down to some low dose. And all these assumptions are turning out to be wrong. Next slide. So Lois Gold, who's here, and I, some years ago, set up the carcinogenic potency database. We took every animal cancer test that had ever been done in the world and put all the results in a computer and calculated potency of the carcinogen and other things. And some interesting numbers came out of that. One is about 60% of all the chemicals ever tested came out positive. What's going on? Natural chemicals, everybody thought were benign. Nature's been around all the time, but you get exactly the same rate in natural chemicals as in synthetic chemicals. And then you start looking at the natural pesticides in plants. Every plant makes 100 toxic chemicals to kill off the predators. All of plant evolution is chemical warfare because they don't have They can't run away. They don't have immune systems. How do plants defend themselves? Toxic chemicals. So every time you eat a broccoli, you're getting 100 toxic chemicals. So anyway, when you test those, half of them come out as carcinogen, just the way pesticides do. Mold toxins, natural chemicals in roasted coffee. Sorry about that. Commercial pesticides, mutagens, anyway, I won't go any more into that. Next slide. So Rachel Carson, back in the 60s, wrote this wonderfully written book, but I reread it recently, and it really made me ill, because Rachel Carson, this is, for the first time in the history of the world, every human being is now subject to contact with dangerous chemicals from the moment of conception until death. But Rachel Carson was made of chemicals. Everything's made of chemicals. It's not a very, no toxicologist thinks much of a statement like that. Next slide. And Rachel Carson, if 5 people did an experiment and one found it did something bad, she quotes the one and she doesn't quote the 4 other who found it didn't do anything bad. So it wasn't really very scholarly, and I think it got people off on the wrong track. So this is cabbage. These are some of the 100 toxic chemicals in cabbage. If you test those, they come out as carcinogen, just the way everything you test, half of them come out as carcinogen. Next slide. And so we did some numbers, and we calculated that we're eating 100 chemicals in the part per billion range from little traces of pesticide residue, really very tiny levels. Part per billion is 1 person in all of China. Unless it's Mao, you just don't want to worry about it. and then natural pesticides, eating 1,500 milligrams in a day, not 0.05 milligrams. And so we calculated 99.99% of the pesticide you're eating are these natural chemicals in plants. Don't you think somebody would want to test those if they were doing animal cancer? No, but a few people around the world managed to test a few. And again, same hit rate. Next slide. And then, so this shows the carcinogenicity status of natural pesticide tested in rodents from our database that Dr. Gold runs. And these were carcinogens, these were not carcinogens, again, about half. So they're carcinogens in allspice, anise, apple, apricot, banana, basil, beer, broccoli, Brussels sprouts, and then a tomato, turmeric, and turnip, and everything in between. So you can't go eat anything in the supermarket that it doesn't have carcinogen in it, because, rodent carcinogen, because half of everything's coming out positive. Next slide. Next. So this shows coffees. Again, sorry about that, but there are 1,000 chemicals that have been described in a cup of roasted coffee. And these are the carcinogen, these are the non-carcinogen, still 1,000 chemicals left to test. So if you're working for EPA, you get, they're drinking their cups of coffee in the morning, but you get more carcinogen in 1 cup of coffee than pesticide residues you get in a year. But so something's funny. Next slide. Well, if it's natural, we can ignore it. But that's not true. We know nature's full of nasty things. So some British toxicologists kind of put this, the aims and achievements of toxicology: illusion, prevent human disease from chemical; the reality, provide living for contract laboratories, civil servants, lawyers, statisticians, consultants, and conference organizers. And the achievement is public reassured that chemicals are properly tested for carcinogenic activity, and the reality is public worried to death or indifference by politicians in sensational press statements. Next slide. So this says, relax, I've come for your toaster. And the point of that is, if you scare people about 1,000 minor hypothetical risks, you're lost, because nobody knows what's important anymore. And there are really important things out there. We're eating a horrible diet, we're getting fat, we're not getting our vitamins, and all this really matters. Being obese is linked to all 40 different diseases, cancer, all sorts of other things. And you don't get your iron or zinc, you batter up your DNA. It's like getting irradiated. You don't get your folic acid. So And the poor are eating horrible diets. So I think they're destroying their brains in addition to all their biochemistry. So there are things to worry about, but the government's putting all its resources in the wrong place. So anyway, now whether that's politicization of science or just misguided enthusiasm or what, I don't know. But you don't want to turn all this into a religion, and that's sort of what it's become. Yeah. Anyway.
Thank you, Bruce. As I mentioned earlier, everyone is invited to register for our event on December 13th, which will feature Bruce speaking more extensively on the sole subject of so-called Frankenfood. I'd like to now turn to our panel of scientists. The first I'm very pleased to introduce is Dr. Sally Balunas. Sally is a staff astrophysicist at Harvard Smithsonian Observatory. She's former deputy director and director of science programs at Mount Wilson Observatory. She's a recipient of the Newton Lacey Pierce Prize and the Bach Prize, and she received her PhD in astrophysics from Harvard University.
This is a brief lesson in history about fear and ignorance of extreme weather 500 years ago. Now, as impossible as it is to comprehend events in the 20th century without understanding totalitarianism, it is likewise impossible to understand Europe's 16th century without recognizing the role of superstition. Magic, witchcraft, sorcery, and superstition pervaded every scale of culture, from the smallest corner to the cosmic. Now, an equable climate had pertained in Europe about 1,000 years ago, and by the 14th century, that had deteriorated into a long period called the Little Ice Age. The Little Ice Age saw harsh winters, severe storms, and also extreme variability. That means you could see mild winters and then very severe winters, summer heat waves, droughts, sea storms, and floods. The Little Ice Age persisted about 500 years, abating only in the 19th century in some places. Now, the most severe period of that 500-year period of the Little Ice Age occurred in Europe between 1550 and 1700. That was also probably the harshest period of weather in the last 1,000 years, if not longer. Now, the severe conditions and climate brought about crop failure, starvation, disease, death, and social unrest. But it was already occurring in a period of great upheaval as the Reformation, the Counter-Reformation, and warfare battered Europe. Now, how unusual was some of this very intense period of the Little Ice Age? On the afternoon of August 3rd, 1562, a thunderstorm struck Central Europe across a front several hundred kilometers long. After raging for several hours, the storm unleashed a terrific hail that continued until midnight. It destroyed crops, it destroyed vineyards, birds, and unprotected horses and cows. Diarists then noted something that we hear today. They said for 100 years, such a storm had not been seen. The storm was deemed so unusual in this period of superstition that it had to be unnatural, it had to be supernatural. Thus, superstition and witchcraft bred a precautionary response. Eradicate those responsible for the storm and this period of new storminess. Now, it was well known that people could cook weather with the help of Satan. So, thus did extreme conditions of the severest part of the Little Ice Age contribute to Europe's most horrific period of mass executions and witch trials. This was completely legal, and it was administered by highly educated upper social strata. These are institutionally legalized executions for sorcery. There are many reasons for these trials, but some of them are related to weather cooking, that is, working with Satan to produce these fierce storms. The average, the estimates now are about 50,000 executions across Europe, and no country was spared of this. Now, there were skeptics who stood up, but they were often accused of, or threatened to be accused of sorcery to squash any debate. So legal philosopher Jean Baudin in 1580 noted that witchcraft was the most terrible problem facing humankind. Again, a very modern note. Baudin championed the international attack against skeptics like Johann Weyer. Now, Johann Weyer is a physician, and Weyer argued that the accused sorcerers seemed to be suffering from what he thought were medical conditions we would modernly term mood disorders. He also thought it was theologically impossible for Satan to work through such people to do his work. Weyer then declared that confessions that had to be extracted by torture because there was very little direct proof of witchcraft, well, these confessions were extracted by torture, and he found this torture immoral. So the response was Jean Baudin decided to accuse him of witchcraft, and so any feeble notes of humane skepticism had to be wrenched out of society. Jean Baudin wrote in response to Weyer's humane skepticism, "Any country which tolerates these skeptics will be struck by plagues, famines, and wars." Now, since it was known that witches caused weather and this unusual weather raged, so did the tortures and executions. How severe did it get? Well, on May 24th, 1626, a hailstorm struck central Germany and dropped 1 meter of hail. 2 days later, an Arctic front descended onto Central Europe and bit hard. Rivers froze, grapevines exploded, the rye and barley crops were destroyed. Tree leaves were blackened and fell to the ground and denuded the trees, and people thought it was Y2K. Now, the Lord Mayor of Zeil in Franconia, Johann Langens, wrote, "Everything was destroyed by the frost, which had never happened in people's memory," which was true. Probably a frost that severe hadn't occurred in 500 years. But since it was so unusual, it had to be unnatural given that century's reigning paradigms. Whereupon, continues Johann Langens, whereupon an intensive pleading and begging started among the rabble. Why did the authorities tolerate the sorcerers and witches? The sorcerers and witches must be punished. So punish them the authorities did. In this area of central Germany, in 1626 alone, Bamberg executed 600, Würzburg 900, in Electorate Mainz 900 more were executed, and Westphalia 2,000. That's just a result of the 1626 frost, and those are directly related to weather cooking. Now, science is the only successful means we know of to explain nature, and growth of wealth is the only successful means we have to afford prediction, preparation for, and survival in order to survive extreme weather, which has always happened and always will. But science needs special societal protection, and without that protection, science will just be dialed out, and in its place will be substituted the myths that humans love to create, myths like weather cooking. Thank you.
I told you we had an interesting program tonight. Our next panelist is Dr. William Gray. Bill is professor of atmospheric science at Colorado State University. He's head of the Tropical Meteorology Project at Colorado State and a fellow of the American Meteorological Society. Bill?
Thank you, David. When I was growing up, I had two heroes. The great pitchers Walter Johnson and Bob Feller. The only thing I wanted in life was to make the major leagues, but I got a knee injury and all that ended. Now, I haven't had any heroes since until last year, and I got a new hero. It's Michael Crichton. Not that I knew much about Michael before I read Aliens Create Global Warming in the last, I think, 35 pages of his nonfiction material of his last novel. But those two items really moved me greatly. And I found, gee, here's a kindred spirit. I've been thinking about this stuff for a long, long time, and I'm older than Michael. Anyways, I have been amazed at how he stood against the tide of this human-induced global warming. That I've been around over 50 years working. I've been all in forecasting, doing research on data, flying into storms, doing all this stuff for 50 years, and I was appalled when the nuclear winter came out, and it was just terrible. And Michael explained it in his article, his Caltech article of January 2003. And the whole global warming thing, I just couldn't imagine how this could come forth and go as far as it did, how people could develop models that were imperfect and believe those models, and how far it has carried. It's amazing to me. And I think the most important thing that Michael Crichton has been arguing is that science must be respected. Objectivity is the thing we need. Politics in science doesn't go. Consensus science isn't science. And I'm going to devote my remaining years. I've still got a little. I'm going to go out kicking and screaming to try to help stop the world from worrying so much about human-induced global warming. Yeah, we're going to have some human-induced global warming. I believe that. I believe the CO2 is going up, and we're going to have warming maybe 0.3 degrees centigrade for a doubling of CO2, not the 2 to 5 degrees centigrade that the models have been pushing. There's a basic flaw in these models, and this is what they do. They take the energy gain that the doubling of the CO2 will bring, warm the surface a little bit with that, get more evaporation and more rain. Nobody doubts this will happen. However, it's what they do with the rain. They take the rain, it goes up into the atmosphere, the condensation warming takes place, and they moisten the atmosphere. More evaporation from the CO2 gain, more rain, more water vapor in the upper troposphere, more blocking of long-wave radiation to space, and the globe warms. That's called the positive feedback loop. And that's where 5 or 10 times the warming comes. If that didn't happen, the warming would be quite modest, 0.2, 0.3 degrees centigrade or something like that. But the error is in the positive feedback loop. It's negative. It's negative as the globe, as you get more rain. Yes, you moisten the area around the rain, but the air that goes up has to come down, either around the clouds or way out from the clouds on the other side of the globe. And that will dry, and there will be more IR loss to space. So that's how I see it. Now, what do I forecast? I mean, I think I want to make a better one than anything you read in the papers from these models. But the globe is warming. There's no doubt about it. But this is a natural change. We're coming out of the Little Ice Age, and we've had it warm, then cool, then warm for instance, the globe warmed a great deal from 1910 to 1940, and then the middle 40s to the middle 90s, the globe somewhat cooled. And now it's been warming again, and I think in 5, 6, 8 years, we're going to see this warming trend stop. I think we'll see some slight cooling, as we saw from the middle 40s to the middle 70s. And we're going to understand what causes climate change. Yes, the globe is warming, but it's natural and it's due to the ocean circulation differences. Now, so I was just amazing that Michael Crichton, not having been down in the trenches for 50 years with this god-awful data sets we deal with, could come out and have a view like I have, and to have the courage to push it forth and stand by himself with it. And I think that's just wonderful. Now, tropical storms, that's where I've done most of my work. We have seen the last 2 years tremendous damage along the U.S. coast. And there are medicine men all around coming out of the closets. We've already seen 2 published papers that the media has jumped on and so on and said, you know, this is due to global warming, and we're responsible for global warming, so we got to cut down on fossil fuels now to stop these storms from coming in. Now, it's just malarkey. I've looked at all the global data. Nobody's looked at more tropical cyclone data around the world than me for a longer period, and I can tell you things are not worse now. What made the damage the last couple years so large is these storms were in an active period. We've been in an active period since 1995. What made the last 2 years so active? They've been very active seasons, but not much more than the other seasons, most of the other seasons we've seen since 1995, but the steering currents, the trough and ridge patterns that set up in the westerlies drove the storms west, and it was the steering currents that brought them in. It had nothing to do with global warming. There's no reason. We haven't had enough global warming to affect tropical storms one way or the other, and the odds verify that. So anyways, I would like to echo my great admiration for Michael Crichton standing up by himself for the truth on this thing, all alone just about. And I found a kindred spirit in him, and it's not that I knew much about him before this. I heard something ER, and I asked my daughter, I said, is that a sequel to that movie E.T. they had about 20 years ago? So I don't know much about Michael's fiction, but I know what he has told in the speeches, and I hope you write this one up so we can read it. And I appreciate coming here, and let's hope that Michael Crichton keeps trying to keep people honest with facts. Thanks.
I want to really quickly, and this won't take long, I want to introduce you to 3 friends of mine. I found myself on the wrong side of several issues, on the wrong politically correct side. But I'm not alone, and the reason, that's me in the middle, or at the bottom, way in the back if you can't see me, that's me right there. These other 3 guys are friends of mine. I haven't met any of them, but I want to tell you about them. 3 people landed on the wrong side of consensus. The first is Alfred Wegener. How many of you have heard of Alfred Wegener before? Yeah, 12 of you. Cool. The rest of you, I want you to read about him. He started out as an astronomer, then he became a meteorologist and climatologist, and then he started playing geologist. And he came up with a concept that's sort of illustrated up in the upper right, the idea of Pangaea. Born in 1880, a bunch of stuff about him. But the nice thing about him is he was this multidisciplinary guy. He started off in astronomy, then he got into meteorology. He pioneered the use of weather balloons and wrote a textbook. And then he got into this geology stuff. He noticed that there were certain fossils and geological formations that were identical on both sides of the Atlantic. Like the oil in Africa matched up with the oil in South America. And if you look at a map, they match up pretty closely. And there were some mountains and some other things. And orthodox science said, well, once upon a time there was a bridge across there. And Wegener said, well, I don't think so. I see these diamonds, and the Appalachians match the Scottish Highlands and other stuff. And he came up with this crazy idea that the continents had once been connected. And this term Pangaea is a Greek for all the earth. Well, that didn't sit too well with the orthodox science. The reaction there in the red was uniformly hostile and often exceptionally harsh and scathing. I mean, this guy was bad news, and he was soundly rejected by the science establishment for a long time. He died in the 1930s, and it wasn't until much later he was vindicated. But this is an example of a guy from the University of Chicago, footloose, hypothesis, considerable liberty, less bound with restrictions and by awkward, ugly facts than most of its rival theories. Well, he was vindicated. Increased exploration of the Earth's crust and the understanding of plate tectonics proved that Wegener was right all along. And this is something interesting that Wegener said. Only by combing the information furnished by all the Earth's sciences, everybody working together, can we hope to find truth. We have to be prepared for the possibility that each new discovery may modify the conclusions we draw. Richard Feynman, Nobel-winning physicist, said, the best scientists are continually trying to prove themselves wrong. Now, I'm a scientist, and it's going to sound like I'm criticizing scientists, and I find not very many scientists actually do this. And I have to say sometimes I'm guilty of not doing this either. It's a lot easier to try to prove yourself right. J. Harlan Bretz, known as a catastrophist. How many of you have heard of J. Harlan Bretz before? Now, if you lived in the Pacific Northwest, you might have heard of him because he's more near and dear to us. He looked around eastern Washington, eastern Oregon, the Columbia Gorge, and you notice these places are pretty dry now, but there was evidence that something really big had happened. Like the one on the bottom is a little bitty waterfall that's in this giant tract of a huge waterfall. And he said, what could it have been that caused this? From the air, you can see giant ripples. It's like ripples in sand on the beach. And then these rocks that are scattered all over that came from somewhere else, maybe from outer space. Who knows? Well, Brett studied the Columbia Gorge. He was a geologist, and he built a case that the Columbia Gorge and the scablands of eastern Oregon and Washington were eroded by a cataclysmic flood from a source that was at that time not known. At that time, science had a theory called uniformitarianism. Say that 3 times real fast. That there were only slow, gradual processes in geology, and if we couldn't see it happening right now, then it never happened before. And his idea was something catastrophic had happened, so they came up with this idea that he was called a catastrophist, that he was flaunting catastrophe too vividly in the face of the uniformity that it lent scientific dignity, etc. This is what the geologists said. Finally, they found the source of the water in the 1940s. He was in his 90s by then. And it turned out it was the ancient Lake Missoula in Montana, which formed after the ice melted after the last ice age. And today the floods are known as the Missoula floods, or often the Bretz floods, in his honor. And in one of these expressions of humble pie that I find kind of cool, geologists got together and telegrammed him and said, we are now all catastrophists. So we're with you, J. Harlan. The last guy is the father of El Nino, Gilbert Walker, who was Gilbert Walker for a long time, was knighted after his death, and he came up with this crazy idea that there was this oscillation in the Pacific involving high and low temperature and pressure that was somehow connected with the long-observed El Nino phenomenon on the west coast of South America. He was studying the Indian monsoons, and a lot of people made fun of him. The problem was that he couldn't figure out how to predict El Nino. And because he couldn't predict what was going to happen, his contemporaries said, well, it doesn't exist. If you can't predict it, it doesn't exist. The really funny thing is we still can't predict it. Even a few months in advance, we can't predict what's going to happen with the El Nino Southern Oscillation, but we know it exists. We know it exists. It wasn't until 1957, 58, which Gilbert Walker died in 58, so he began to see the fruits of this happening. The first global measurements of the ocean and atmosphere were made, and it happened to coincide with a warm event or an El Nino, and he was vindicated. Conclusion. First of all, read about these three. How many of you have never heard of Gilbert Walker before? Never heard of him before. Lots of you. Okay, Gilbert Walker, J. Harlan Bretz, Alfred Wegener. Read about them. Great stories. But the history of science is filled with stories like those. Unpopular ideas which conflicted with consensus and which proved to be true. Thank you for your attention.
Thank you, George. We have many questions. We'll try to get to as many as we can. Procedure I was going to use was I would read them and direct them to whoever is being asked. Our first question is from Michael Crichton. It says, you have written about how the old media dinosaurs would collapse with the digital revolution, but now you oppose Google. Plan to scan books for search. Is this a losing battle?
Is this a question about the Authors Guild lawsuit? I mean, is that?
Yes.
Oh, okay. Well, I'm not really very knowledgeable about it. I'm sorry. Next question.
Next question. How do we tell genuine disaster predictions from the ones which are made up?
Oh, it's still on? Okay. I'm often asked this, and I think if any of you have had any experience in litigation, and unfortunately I have, you understand that in a legal context, there is a tremendous onus that is placed on somebody once they've stated a falsehood. And they're sort of never really trusted again. And I think without particularly pointing to any of the people that I was talking about this evening, if you just look at the general set of scares that we've been subjected to in the last 50-odd years, it would give you a lot of reasons to be skeptical just at the outset. And, I think that there's a lot of reason to think, one of the most difficult discussions that I have is people say, well, we have to act now. And I say, why? We don't have to act now. You can act in 20 years. If you want, in fact, you can act in 50 years. If you look at the speed with which this country electrified and compare that to what it might take if, in fact, we were to really decide we have to convert the entire energy economy of the United States to non-polluting sources. It's a huge problem, but we can do it, I think. We would, first of all, cover the entire state of Massachusetts with solar panels, but or perhaps part of Texas. The real question is, do you have to do it now? And the answer is no, you don't. And since solar panels are getting better every year, since the cost of electricity generated by all these sources is declining, why do you have to do it now? Particularly since there are a number of thoughtful people who think this is a problem that may very well take care of itself. In other words, 100 years ago, there were no airplanes and there were essentially no automobiles. Now there's 10,000 airplanes in the sky at any given moment and millions of automobiles, and we all sit in traffic cursing each other. But the question that I have is, do you really believe that 100 years from now we will still be living in exactly this way? I don't think so at all.
Next question. This is from Michael, and some of the other panelists might be interested in commenting also. What do you think of the UC San Diego study that reviewed 928 peer-reviewed articles, but found not one that challenged the quote-unquote consensus that global warming is human-induced? Go ahead. Yeah. Anyone?
It's a...
You want to do it?
Excuse me, those articles found that human-induced global warming was human-induced or not human-induced?
The claim was that they reviewed 928 peer-reviewed articles and there was not one that challenged the consensus view.
Oh, yeah.
There was an article in Science by a woman named Naomi Oreskes
Right.
who did a Google search on the term climate change, and according to her research, none of the articles that she found suggested that anything besides human-induced climate change was really a significant factor in climate change itself. It's been widely refuted by a lot of people. There are literally hundreds of journal articles which indicate that natural variations are a major component of climate change. Now, I don't know anyone that denies that human influences do not affect climate. I think we all do. Mostly it's a matter of degree. And many people believe that natural variations are more significant, some much more significant influences on climate than the human component is. That's certainly what I believe. I don't want to speak for Bill Gray, but I think he believes that too. None of us really knows what's going to happen in the future. But I think in terms of what's happened in the past, many of us believe that the natural variations are very, very large indeed.
Well, I'd like to make a comment. It just shows you how we've all been brainwashed. That's what that article said. And of course, the people that publish papers, most of the journals are a bit, they like to reject papers that don't follow the conventional view. And most of the people that get research and funding have to follow the conventional view. So it doesn't surprise me that the majority of people don't challenge it, but I wouldn't think all of them would follow that. All we could say is brainwashing. We've all been brainwashed.
Can I make one comment?
Yeah.
My understanding of what Oreskes did was that she did, as George said, use certain keywords, and you can enter those keywords in the database and come out with the same subset of articles that she had. But in the last 10 years, there are approximately 11,000 climate articles, give or take, of which she found some 968 or 78. And she concluded that, as David said, none of them had any confirmation of any thesis except anthropogenic global warming. Well, the articles have been reviewed again, and what no one will say is that it seems as though, in fact, the abstracts that were claimed to have been read weren't read, because the biggest set of articles among the 900 odd is something like 40% have actually nothing to do with climate at all, or temperature anyway.
The next question is, and this is also from Michael, what do you think about the prediction of death of the avian flu?
Do I think it's going to be a pandemic? Is that what that question is?
Yes, that's the question.
How would I know that? Look, the presumption is that the 1718 flu was an avian flu. A flu virus can mutate rapidly. The presumption is that at that time, the lack of immunity that people have to the avian flu decimated them because the avian virus, which only affects birds and people who are in direct contact with birds, jumped into another influenza virus and ran across the world. And the concern is that this will happen again. I don't know if it'll happen again. The only thing that I would suggest to you is that one procedure that people use now to make fears is they say, I don't know the answer, so let's all be afraid. You know, another way to do it is to say, I don't know the answer, so let's stay calm and try and find the answer.
One thing I might add, this relates to a number of the questions also, is one of our fellows is an economist by the name of Bruce Yandel. He's an economist at Clemson University. He's done a lot of work in law and economics, and he coined a term that is used commonly to describe the process of adopting and supporting different government measures. It's called the Baptist Bootlegger Alliance. And what he means by that is that every single government policy that is adopted is a combination of true believers who believe, for whatever purposes, that the outcome of that measure will be something positive is the way they see it, in alliance with interest groups that use government measures for their own purposes, to shift resources, to use government restrictions against their competitors, whatever, to enrich themselves through government power. And I would suggest that the flu epidemic, like many of these crises, need to be looked at a little more closely to see what kind of interests actually are talking about them. And of course, the controversies over climate change is part of that question. Another question is, and this could be for any of the panelists, are not many of the negative forecasts of dire consequences based on computer simulated models lacking in hard data? So this could be, I suppose, the climate models or other models.
The atmosphere is very, very complex. It's like a teenager. And to boil down the incredible complexity, we call it a chaotic nonlinear system, which means it's really complicated and we don't fully understand it, into a set of mathematical equations is a really tough thing to do. We know that because I think we all know that weather forecasts don't work real well more than sometimes a few hours in advance, usually a few days in advance, and most weather forecasts now are done with computer models. We're getting better, but we still have a long way to go. So the complexity is still so overwhelming that it escapes our ability to simulate it mathematically. It really would be like simulating the behavior of let's say a 2-year-old. You put in the governing equations that affect a 2-year-old, the eating habits or potty habits or sleep or what have you, and try to simulate that with a computer, and it'd be a really tough thing to do, and it's almost as hard in the case of the atmosphere.
Here's a question. This is for Michael. It says, you're rightly critical of hysterical fear-mongering writings, yet wasn't the subject of one of your books, Nanotech Run Amok. Please explain.
You know, a lot of my books have been about sort of science gone wrong, and I'm always surprised that anybody takes it seriously. When Jurassic Park came out, there was a congressman who was going to introduce legislation banning any research leading to the creation of a dinosaur. I held my breath, hoping to see this happen, but apparently somebody whispered in the guy's ear that it was just a movie, you know? It was, the book that I wrote about nanotechnology is a sort of Frankenstein story, and it discusses technology that is A, impossible at the moment, and B, impossible next year, and C, impossible probably 10 or 20 years from now. I don't really think there's a reason for anybody to be distressed. Enjoy the book.
I enjoyed the book, I'll tell you that. There's a number of questions that are asking about your views of the op-ed in today's Chronicle. Is there anything you want to say in response to?
I only glanced at it briefly, but it looked to me like there were two articles, and they both said that they were both on the same side of the issue. Is that not right? Yeah. That's balanced.
Okay.
What was the op-ed? Yeah. I don't know. I don't live here. I was just, coming in from the airport.
Well, the interesting thing about the op-ed is that when we announced our program, we made it clear that Michael was not coming to speak on global warming. He was coming to speak on the issue of politics and science. But clearly that touches significantly on the global warming debate. And the irony, of course, is that his topic is on the politicization of science, and it seemed like the very response people had in some quarters was the politicization of science. And where they, on the one hand, people didn't believe, some people don't believe that Michael should be speaking on the subject. They keep on demanding that he address the topic. So there's a number of problems, I think, in all of this. Let's see. Okay, we have time for just 2 more questions. Since you've addressed the issue of fear and complexity, what is your prognosis for the future of informed analysis of environmental issues? Are you optimistic?
You know, I'm a congenital optimist, and I think it's a characteristic of personality rather than a reasoned assessment of the situation. Bill Gray and I both did some Senate testimony a few weeks ago, and I don't know what his reaction was, but it was the most depressing experience of my life, you know, short of major surgery. And you know, to perceive that any kind of objective assessment could occur in this kind of carnival setting, it was I don't want to say it was more like a Stalinist show trial, but it had highly theatrical aspects that did not appear to represent the search for truth. I think that we will finally have to come to terms with the kinds of issues that I was talking about today in terms of Yellowstone. It's going to be too obvious that we don't know what we're doing with the environment, and it's going to be too obvious that we really don't understand it, and we ought to stop pretending that we do. And once we begin to treat it as something we don't really understand, but we're working to try and manage, we'll have much better results. But it's going to be a large change.
Last question is, your work or talk on complexity theory certainly seems to explain a great deal of what's happening, or our lack of understanding of what's happening. How would you suggest that be used to look at economic questions?
Well, my understanding is there's plenty of interesting complexity theory among economists already. I mean, I think that's happening. Is it not?
Yeah, definitely. Okay, well, I want to thank Michael Crichton for taking the time and interest and putting himself, as Bill has said, on the line on some of the most important issues that we all face in the U.S. and around the world. Information is important, but information that is not based on reliable evidence can be very damaging. Michael, I think, deserves a special applause, and if you join with me, I want to thank him again. I also want to thank our panelists, Sally Balunis, Bill Gray, and George Taylor, for their joining with us. Their wonderful comments. I want to thank Bruce Ames also for his wonderful comments. As I mentioned, Michael will be out in the lobby in just a few minutes to autograph his book. For those of you who do not have a copy, there are plenty of copies both in cloth and paperback. You can also register for our event on December 13th. Thank you for joining with us and making this such a successful program. We look forward to seeing you in the future. Thank you and good night.